Statistics for Business students. We're moving on to learning outcome 4 of the course on probability distributions. In this lesson, we're specifically going to focus on discrete probability distributions. You can fill in your name and student number. This will be your solution file. Again, we're going to break this down into 3 videos for the 3 sheets found within the lesson, just so you can watch them at your own pace and you don't have to watch a video for such a long period of time. So in Learning Outcome 3, we learned about probability. Probability is different than just descriptive statistics like the mean, median, mode, standard deviation, and variance because those statistics summarize data that's already happened. When we talk about probability, we talk about things that could happen. There's some randomness involved. In this learning outcome, we're still going to be talking about probability, but we're going to talk about an entire range of values that can occur in a distribution. Before we do that, we need to do some definitions. So the first definition is the random variable. A random variable basically is an assignment of every outcome that can happen in the sample space of an experiment. To give a simple example, if you flip a coin and you have a random variable from that coin flip, you could say that X would be 1, you assign it a number if you toss heads, or X would be 0 if you toss tails. We usually define random variables with capital Latin letters like X, A, B, C, Y, any of your regular letters. So in this example, with flipping the coin, we could assign a 1 to X if you have heads, or a 0 if you toss tails. The important thing is you want to list out all the possible options you could have for X for all of the outcomes in the experiment. To help you understand random variables and other concepts in this lesson, I'm going to introduce an example of a dice game. We won't be able to play it in the same way that we would play in a live classroom because we're not all in the classroom together where we can share our scores in the game. But I'll still explain the game and show you how it works because, like I said, understanding this game will help you with all of the concepts in the rest of the lesson. So this game is called Greedy Pig, and how it works is you roll one die and you get the score that's showing on the die. So if you roll a 1, you have a score of 1. If you roll a 2, you have a score of 2. The trick is if you roll a 5, you lose everything. So you can keep rolling in the game as many times as you want to try to increase your score, but as soon as you roll 5, you lose. So the trick is you want to stay in the game for as long as possible without losing, but you don't want to roll 5 so that you would lose all your points. It's kind of like gambling in terms of when you need to stop rolling because you're afraid you might get a 5 and when you should keep going. So we can do a round here where I'm going to do my first roll to see what I get. So I got a 2. So I have a score of 2. I'm going to keep rolling another time. I got a 5. I'm already out. So if you rolled the 2 dice along with me and you did not roll a 5 on your first or second roll, you're the winner in our game of Greedy Pig. So I already lost because I rolled a 5 on the second roll. But let's pretend that I'm one of the students in the course and I did 2 other rolls against me. 2 and 3, they would have won because they had a score of 5, whereas I got out. So my imaginary student, imaginary, won with a score of 5. They only had to roll twice, and I already lost because I got a 5 on my second roll. So those are the possibilities with Greedy Pig. So for example, if we're talking about random variables for your score in Greedy Pig, if we call X your score, you could have a score of 1, you could have a score of 2, you could have a score of 3, you could have a score of 4. On the first roll, if you roll a 5, you'll have 0 points, you'll have lost. And on the first roll, if you roll a 6, you have 6 points. And that's in one roll what the possible options for random variables are for Greedy Pig. You could try the game a couple of times. That's what we normally do in class. But like I said, we can't really share our scores with each other through the online game. But as long as you understand how the game works, you're basically trying to gamble on when you should quit with your score when it's high enough. If you're afraid you will roll a 5 and lose everything. Once we understand the basic definition of a random variable, and for Greedy Pig, for example, these are the options that you can get, we can further classify random variables into two main types, discrete and continuous. We already learned about discrete and continuous variables in general, and the definitions are really the same for random variables. That discrete are things that can be counted, that only have a limited number of possible outcomes, whereas continuous random variables are measured and can take any value in an interval. That means that they can have decimals. I have some examples on the side here that we want to classify as either discrete or continuous. So the number of red cars in a parking lot, think about if that's something that you would measure or something that you would count. So that's something that you would count, so it would be discrete. The distance a ball is thrown, is that something you would measure or something you would count? You would measure it, so it's continuous. Blood alcohol concentration, again, it's something you have to measure and it can have a decimal, so it'd be continuous. And finally, if a person passes a driver's test or if they fail, that would only be two options, kind of like flipping a coin. So that one would be considered discrete if we have a number for those outcomes. So now that we've talked about the two possible types of random variables, we can start to actually work with looking at all the different possibilities. Because like I said, we already learned about probability in learning outcome 3, but now we want to look at all the possible options available. How we do that is we put them into a table that's like a frequency table for data, but it's a table for probabilities. We call the name of this table for probabilities the probability distribution. So think about for Titanic that we could count up the amount of people that lived and died. It's like that, only instead of listing all the possible options for one variable, like survival, this will list all the possible outcomes of an experiment and the probability of each of those outcomes. Because we're still working with probability, our main probability rules still need to be true. So probabilities must be between 0 and 1, where 0 means it can't happen and 1 means it always happens. The outcomes must be mutually exclusive. That means that they can't overlap with each other. One has to be definitely different than another. And the list of all your outcomes that are listed for the experiment must be exhaustive so that you don't miss any. And when you add up all the probabilities, they always add to 1 or 100%. So to show you how a probability distribution works, we're going to build some together. First, we're going to work on Greedy Pig, and then we'll work with rolling a die. So if we let X, the random variable, be the score in the game, then the possible options for X we'd have to list in a table. I already listed those options for playing Greedy Pig here, from 1 to 6, where the 5 has an exceptional rule to it, that if you rolled it on the first round, you just get 0 points, you lose. Everything else, the number of points is what you roll. Also, when we talked about rolling a dice, what was the probability of rolling any of the sides? There's 6 sides, so the probability is 1 in 6. And that number is true for any of the sides you could roll. For a probability distribution, you need to check that they all add up to 1, and they do. So this is a simple probability distribution. It shows you all the possible things you can roll associated with their probabilities, where the probabilities are between 0 and 1, and the total also has to add up to 1. A little bit more of a complex example of a probability distribution is the sum of the rolls of 2 dice. If we use some of what we learned about the multiplication rule, Because we have two dice, if we look at the outcomes from the first dice, there's 6, and the second dice, there'd be 6. So there's 36 different possible combinations for rolling a die twice. But if we talk about the sum of the die, you could roll a 1 and a 1, so the sum is 2. You could roll a 1 and a 2, so the sum is 3. Or you could roll a 2 and a 1, so the sum is 3. You could roll a 1 and a 3, so the sum is 4. You could roll 2 and 2, so the sum is 4. Or you could roll a 3 and a 1, so the sum is 4. If you roll a 1 and a 4, you'd get 5. Or if you roll a 4 and a 1, you'd get 5. If you roll 3 and 2, you get 5. And if you roll 2 and 3, you get 5. I think that's all the possible options. Then for 6, you could roll a 1 and a 5. You could roll a 5 and a 1. You could roll, oh, oops, that warning popped up and it moved my pen. You could roll a 4 and a 2. You could roll a 2 and a 4. Or you could roll 3 and 3, where the threes are interchangeable. I think that's all the options for that one. Then for 7, you could roll a 1 and a 6. You could roll 6 and 1. You can roll 5 and 2. 2 and 5. 4 and 3. Or 3 and 4. That's a good start. I'm going to start putting those options in the table. So 2, 3, 4, 5, 6, 7. And we'll look at how many possible ways you can get them, because we know there should be 36 in total. There was only one option to get 2, 1 and 1. So 1 and 36. For 3, we had 2 options. In 36 total you should have. For 4, there were 3 options in 36. For 5, we had 1, 2, 3, 4 different ways. In our 36 we should have in total. For 6, we have 1, 2, 3, 4, 5 different ways out of 36. For 7, we have 1, 2, 3, 4, 5, 6 different ways out of 36. After that, they actually work backwards. So for 8, the options for 8, you should have 5 of them. So it could be 6 and 2, 2 and 6, 4 and 4, 5 and 3, or 3 and 5. So that will be 5 different options for 8. For 9, you should have 4 different options. 6 and 3, 3 and 6, 5 and 4, or 4 and 5. So that will give me 4 options. For 10, there's not that many options. 6 and 4, 4 and 6, or 5 and 5. That's 3 and 36. You can get a sum of 11 just with 6 and 5, or 5 and 6. Those are the only 2 options. And finally, with 12, there's only one option, 6 and 6. Together, if these add to 1, that means I have not forgotten any, and they do. I didn't write out all the other ones because I'd run out of space, but once you do the first half, you see the pattern and it actually works backwards. What I mean by that is if you look in the middle of the table, that's the highest probability at 6 and 36. Before that, you move up from 1, 2, 3, 4, 5, 6 in 36, and then you work back down. 5, 4, 3, 2, 1 in 36. And that is the probability distribution. where X is the sum of the rolls after two rolls of the die. It's a probability distribution because we've listed all the possibilities with their probabilities, and they add up to 1. So this is your basic probability distribution. In the next video, we'll talk more about computing statistics like the mean and variance for probability distributions.